Hello students. So in the last lecture we were discussing the nuclear reactions and we discussed some type of the nuclear reaction. Now for a nuclear reaction to happen we need to conserve some quantities. Okay. There are some quantities like conservation of let's write those quantities. The conservation of mass number. What happens to what quantities? Okay. So first and foremost thing is the conservation of charge. Second thing is conservation of mass number. Third thing is conservation of atomic number. Fourth thing is conservation of energy. Fifth thing is conservation of linear momentum for an isolated system. Sixth thing is conservation of angular momentum. Seventh thing is conservation of parity. And then eighth thing is conservation of isotopic spin. Okay, there are some next okay, so let's discuss these things. For a nuclear reaction to happen, these quantities should be conserved, like conservation of charge. For the total charge before and after the nuclear reaction should be same. If the initially the total charge before the reaction happened, we have a particular amount of that charge, and after the reaction happen we must have both the charges equal. Like in this process, boron with the neutron does not have any charge. Boron nucleus has 5 units of positive charge. Then it gets converted into lithium with respect to the alpha particle. Then alpha particle has 2 units of positive charge and lithium has 3 units of positive charge, and the total charge happens to be equal in both the before the process and after the reaction. Okay, so in any reaction, any nuclear reaction, conservation of charge should happen. Next thing is conservation of mass number. So you can have with respect to the same nuclei, here the mass is 1 unit of atomic mass and 10 units here, so total units are 11, and here we have 11. Okay, we cannot write anything like charge. Now in this, if I add something like this, then obviously charge is conserved in this case, but the atomic mass number is not conserved, so we cannot have this kind of reaction. Okay, so we cannot have this reaction. Now the next thing is conservation of mass energy. Now for a reaction to happen, more precisely, if I say that if initially the reactant particle has more mass and they get converted into the daughter nuclei and they have less mass, then the defect mass or the loss of mass will transform itself into energy. Okay, and that energy will be the released energy during the process, the liberated energy. So mass may get converted into energy. In terms of energy and mass, we can say conservation of mass and energy. And we studied in every reaction we discussed that there happens to be conservation of mass energy. Okay, Next thing is conservation of linear momentum of the interacting particle before reaction is equal to the total linear momentum of the products. For example, you might have studied this kind of reaction in which the parent nuclei is at rest, and it just decays into two daughter nuclei. The first daughter, like if I say in the alpha decay model we studied that the parent nuclei gets decayed into alpha particle plus a daughter nuclei y, right? So we did conserve the momentum, linear momentum, and then we calculated that the linear momentum of this alpha particle must be equal to the linear momentum of this daughter nuclei, and both have opposite direction if this was at rest. Okay. Then the next process is conservation of angular momentum. Now the conservation of angular momentum states that the total angular momentum I is the vector sum of the spin and orbital angular motion momentum. Then I is equal to s plus l. In a nuclear reaction, the total angular momentum of the interacting particles before the reaction is equal to the total angular momentum of the products after the reaction. Okay. Next thing is the conservation of spin and statistics. Spin must be conserved as well, like remains. Now this spin and special statistical character remains same before and after the nuclear reaction. Therefore the statistics followed by products is same as followed by the interacting particles before the reaction. Now for nuclei like with even mass number, they follow the Bose-Einstein statistics, and for the odd nuclei they follow the Fermi-Dirac statistics, and they happen to be same before and after the collision. Okay. The next thing is conservation of parity. Now we know there are two kind of parity. One is odd parity, even parity. Okay, so they need to be conserved as well. Okay. So these were some conservation laws you need to study. Now in the next lecture we are going to discuss the kinematics of the nuclear reaction. Okay, thanks.